I had that happen last year.
Okay. We're going to graph the logarithm, log base 2 of x minus 1. We're going to do this by doing a transformation. What kind of a transformation do you see that's taking place in this function?
It is going to the right one, and that is as much as I can tell you because I don't know the log does logarithm does it.
Shifted right, 1 unit. So what I'm going to do is I'm going to graph a related function. Instead of graphing f of x, I'm going to graph g of x. And g of x is going to be log base 2 of x. Okay. So we're graphing that. Let's rewrite it in exponential form. The base is 2. The power is
Y.
4y. The thing is
X.
x. We're going to graph this related equation. So we'll make our t-table. Remember, we're plugging in values for y instead of values for x. So -1, 0, and 1 would be 3 that we always check. And Luke is like, what the heck's going on?
Yeah.
It's a beautiful thing.
When's the last time we did that? Friday.
Okay, so plugging in a -1 for y. 2 to the -1 power is?
-2. Oh, that's awkward.
Wait, 2 to the y?
2 to the
It's
-1
1 over
power.
2. It's 1 over 2. That's
Okay.
awkward.
Okay, negative exponent is just reciprocal. 2 to the 0 power?
1.
1. 2 to the first power?
2.
Okay, we'll plot those points. We have the point 1/2, -1. It's there. 1, 0. And 2, 1. We know that the y-axis is a vertical asymptote. I do not want to plug any values with lower values of y because I know it's just getting closer and closer and closer to the y-axis. I do want to see how high this thing goes, so I will go ahead and plug in some higher values of y. I've already done 1, so let's do 2. 2 to the second power.
4.
4.
Plot the point 4, 2. Plug a 3 in there.
8.
Plot the point 8, 3. Okay. This is the graph. I'm going to go and draw the line here. I'm going to draw the graph of g of x, which is log base 2 of x. So we have a vertical asymptote really close here. I don't know if it's drawing or not. It is good. Okay, so here is log base 2 of x. But that's not what we were asked to graph. We were asked to graph that function. So f of x is the g of x function shifted to the right 1 unit. So I'm just going to take each of these points and move it over 1. Where's my vertical asymptote? Does it move to?
No.
No.
Thank God.
Wait, but you said it didn't move, it just can't touch the other one.
Okay.
Oh. Okay. Yeah.
Okay?
Wait.
So, the blue graph is drawn there. Look at the blue graph. What is the domain of f of x?
The domain is 1 or 1 comma infinity.
With parentheses, because it can't be 1. What is the range of the blue graph?
Negative infinity.
Okay, done. Questions on this one? Luke has a bunch, but has no idea where to start. Okay, next slide. We're going to graph log base 3 of x minus 1.
Is it a stretch?
Nope.
It's just.
Luke, what transformation is taking place?
It's down one.
Down 1. So it wasn't even here, but you know, because transformation rules don't change.
That's good.
Okay?
Yeah.
Okay. So we know it's shifted down 1 unit, and we'll do just like I did on the last one. I will graph the related function. I will graph this g of x, which is going to be log base 3 of x. And this is going to look an awful lot like the one we just did, right? I mean, we just did log base 2 of x, now we're gonna do log base 3 of x. The graph's gonna look so much the same. What's the base?
3.
Power?
Y.
Thing.
X.
As normal, we're gonna check our values of y being -1, 0, and 1. 3 to the -1 power,
1/3.
3 to the 0 power,
1,
3 to the first power.
3.
Okay. 1/3 -1. 1, 0. 3, 0, 3, 1. Let's go ahead and go bigger y values. When y is 2, x is
6. 9, sorry.
9, 2. Okay. And f of x is simply the exact same graph, except we're moving every one of those points down 1 unit. So here, 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 here. Is the asymptote gonna change?
No.
No, because it didn't shift horizontally at all, okay? What is my domain? For the blue graph, x can be what?
1, 2, 3. 0 to
0 to infinity. Range?
negative infinity to infinity.
Coming together at all?
A little.
Next one. What transformation has taken place?
Moving to the left 2 and out 1.
We'll graph the related function g of x equals log base 4 of x, or log of x base 4. Base is
4 to the y equals x.
Don't be so excited.
Sorry.
T table. -1, 0, and 1. When y is -1, x is.
1 point.
When y is 0, x is.
1.
When y is 1, x is 4. Pretty much the same again, huh? Plug in 2.
16.
That's terrible. Anyway. Okay. And now we're going to go ahead and do our translations on each of those points. Left 2, up 1. Where is our asymptote?
2 units to the left.
-2.
-2. Everything moving in 2 units to the left, that means the asymptote went right with it. So our domain now
-2 infinity.
and range.
Negative infinity.
And that's graphing logarithmic functions. Okay, we're now going to look at some properties of logarithms. And I always thought these were fun. Kind of got a weird, twisted mind. Working with logarithms to me, it's like working a puzzle. And it's just the satisfaction of completing a puzzle. But these are the properties you need to either have memorized or have on your piece of paper that you're going to have handy when tests might come around. But they're not difficult to remember these. If I'm taking the log of a product, so the log of x times y, that's the same thing as the log of x plus the log of y. If I'm taking the log of a quotient, that's going to be the positive log of the stuff in the top, negative log of the stuff in the bottom. And I said it that way for a reason. So everything in the top is going to have a positive log, everything in the bottom is going to be a negative log. It kind of makes sense. Multiplying and addition go together many times, and division and subtraction go together all the time as well. The power property says if I'm taking the log of something that's raised to a power, I can take that power and pull it to the front. So the log of x, guys, I'm not going to keep saying base, 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 base all the time, okay? You can see that there's a base there. Okay, so the log of x to the r power, I can pull that r to the front. So the log of x to the r power is the same thing as r times the log of x. When you take the log of 1, it's 0. Always. The log of 1, I don't care what the base is. The log of 1 is 0. And this one I'm going to say the base. The log of a, base a, is 1. The log of 6, base 6, is 1. The log of 3, base 3, is 1. Okay. And believe it or not, that's a very important property. So that'd be a good screenshot there for you. I'll just do it one more time for those who are writing it down.
No, you can't.
You won't make it.
Whatever.
It didn't make
I was
it.
expecting a bounce, but it didn't.
I just kind of want to point out, you said it's like a puzzle because the end result is so satisfying. Puzzles are also very annoying because if you lose one piece, you want to like murder everyone in the house, and they take 8 years.
Well, these are satisfying to me because I struggle with regular puzzles because of color vision issues. So I've got to come,
The only puzzles I enjoy doing are the 4-piece ones.
you can't even do those.
No, because I mix
Oh,
up the
mission
corners.
the glory.
Yes.
Do you want to see my, my thing that Preston put on here?
Probably not.
Why are you so pink in that?
I have no idea. Okay, so here we have the log of a product. The directions here tell us to simply rewrite the expression. Okay. The log of a product is the sum of the logs, right? So I have log base 6 of 7 plus the log base 6 of 9. That's the book's answer. But I guarantee you, if I was to do this problem, that would not be my answer. So maybe I'm getting ahead of things. I don't really care. I'm going to do it anyway. Can you write 7 as some number to a power? Or is 7 pretty much what it is?
I mean, to the first power.
Other than to the first power.
What it
Yes,
is.
Okay. Can you write 9 as some base to a power?
Yes, 3 squared.
Okay. So if I was working this problem my way, I would have started here, just like that. I would have gone on. I would have said that, well, this is log base 6 of 7 plus log base 6 of 3 squared. Because 3 squared is 9, right? And what was that property about powers? What do you do with that 2?
You square root it.
That 2 is going to come to right here. So my final answer would be log base 6 of 7 plus 2 log base 6 of 3. That would be my answer for this problem. I was always taught when you're given an answer in log form, your final answer, whatever that number is not going to be some power, like 9 is. Okay? Questions on that? Okay. Next one's division. Log base 9 of 15 over 7. Anything on the top is going to be a positive log. Anything on the bottom is going to be a minus log. Okay? So the 15 is on top, right? So as I redo this, I'm going to write this as log base 9 of 15. This is positive because 15 is on the top. I now have a 7 on the bottom. So minus log base 9 of 7.
Whoa.
And I'm done with that one. These are gonna get pretty messy. What's your question?
I usually tend to.
What?
I usually tend to get worse. You beta sim with the.
Yeah, these build, I think letter E or F, I forget which one's the last one, it's pretty nasty, but it's not that bad.
It's pretty nasty, but it's not that bad.
D, E, F.
Here you go,
Yeah, this looks nasty.
log base 5 of the square root of 8. The first thing I would like to do is get rid of the square root. So how can you write this without writing the square root? 8 to the
It's like 2 over something, right? No, it's not. It's like
1/2 power.
Yes.
The bottom number is the index, right?
Yes.
So if this is a square root, then there's a 2 right here. So I could write this as log base 5
8.
of 8 to the 1/2 power. How about the 8 though? Can you write 8 as a base to a power?
Yes.
8 is equal to
2 cubed.
2 to the third. So I'm now going to write this as
2 to
log base 5 of 2 to the third to the 1/2.
Forgot what to do for that.
Okay? When you raise a power to a power, what do you do with the exponents?
Put it in the front.
Multiply them.
I was just kidding.
So 3 times 1/2.
1.5 or 3 over 2.
Okay, so I have log base 5 of 2 to the 3/2 power. Now what do I do to that 3/2?
Put it in the front.
Pull it in front. So I have 3/2 log base 5 of 2.
That's not that bad.
Speak for yourself.
I really don't even know what the heck a log means.
I did kind of forget that you haven't been here.
A logarithm is an inverse to exponential.
Did he learn about the E? Did you learn about the E?
Well, we're not doing natural logs. We don't care about the
No,
e's right now.
but I wanted to know if you know about the E. I don't
Oh,
remember the E.
E's confusing.
E is 1.8 or no, I don't know.
2.718281828.
It's
I
another
remember the
pi.
number it was.
Take your word for it.
Okay, part D,
Ooh.
log base A of the cube root of m squared.
M two to
To the 1/3.
2/3.
No.
Yes and
Yes.
yes. We're gonna wait before we get to what you said. Okay, so this will be the log base A, it's like a 9. Log base A of m squared to the 1/3 power, because that takes care of the cube root.
Oh, it's
And then
Okay.
you
But if you raise a power to a power, you multiply those exponents.
and it makes it 2 bits.
So we have log base A of m to the 2/3 power.
bring it to the front.
Go ahead.
Didn't you just put the one on the inside on top and the?
That's what we did. Yeah.
Without the extra step,
Yes.
so all this work.
Okay. I would have gone from this to what I'm about to write down. Okay? 2/3 comes up front.
This.
Yes. And
See, look that.
I would have gone from here to here. Because I can look at that and write that. No problem.
You also have a master's.
I've had a little practice.
I mean, you did say these were like your favorites, so.
How we doing? Okay, next one.
Oof.
Again, I would go straight to the answer on this one.
I think I get it. Never mind.
I see it.
Well, it's gonna be log A, and then it's gonna be MQ minus log A P squared T to the 4th power.
You're not done.
Okay, but I'm there.
Yeah,
I'm on the
on
track.
the trail.
What she
On-
said.
The Golden State Brick. Golden Brick Road.
Or at least we're on the same continent. Yes.
Same concept.
You gotta say the golden
MNQ.
MNQ.
Did you think that was a Y?
MNQ.
Okay.
I said P.
So this is log, and again on this one I will go straight to the answer, but I'm gonna write an extra step here. Okay, this is log base A of m. Anything on the top is positive. All of the products on the top are positive. So that's a positive log base
Oh,
A
we
of
have to
n.
do all of them?
Plus
No, we don't.
Oh my goodness.
log base A of n. Plus
The frick.
Log base A
Q
of Q.
minus.
Everything on the top is positive because it's a product of those three things.
So you can't just do log A of M plus N plus Q.
No, because M and N and Q are multiplied together. And now you're trying to add them together? That's not the same thing. Okay? Now, the stuff on the bottom is subtracted.
Minus log A.
Minus
2.
log base A of
P squared.
2.
P squared, but it looks like we're about to have another step. Or you could have done this in one step. Yes?
Isn't the 2 supposed to be in front of them?
Ooh,
That would be the next step, or doing it now.
wait, does the.
Either way.
Okay.
If you're going straight to the answer, yes. Okay,
It just depends on your brain speed.
minus
T.
log base A of
T squared.
t to the fourth, but
Wait, no, never mind.
as she was pointing out, we can't have exponents. Those exponents need to come out in front of their respective logs. So you could have actually gone straight to this answer. If you would have written the 2 here and the 4 here, that's the correct answer.
Oh, that's all.
Log A M plus log A N plus log Q minus log, or 2 log A P minus 4 log A T.
I don't think
Well,
it's
okay,
really
speak.
helping me right now that chemistry is starting to look like algebra.
I feel like I'm speaking in
Like the
another
answers are the
language.
same thing.
Does algebra 2 count as a second language?
Do what?
Does algebra 2 count as a second language?
No, computer science does.
So I've been saying, like, especially at this school, passing periods should count as a PE credit, right? If you have 7 passing periods a day,
Honestly,
that should be a PE credit. So we should get 9 credits. Everybody automatically gets a PE credit because you have to walk from here to Ag.
Oh,
And then
yeah,
back.
that's annoying.
And
Next
then
year I
back.
have to do that 3 times.
I mean,
a day.
try just going up that hill.
I don't like,
Okay. You're at, yes, you were right on, right? You were going straight to the answer. Okay? And that's how I would have done this one. The next one, which was even uglier, I could go straight to the answer on it too.
Okay, well, I say we do that.
messing up my
Because
we're not gonna
organization.
do it. Okay, this is recorded. You're not gonna sit there and say that we do. No.
It kicked me out of the,
Do.
I got back in.
Why is B on the bottom now?
That's the base. It doesn't matter.
It's
Okay.
just
So
a
what the
heck
it's a variable.
Okay, I see it, I think.
And I see
At
it.
this point, you're just like drawing random symbols.
Second language.
Exactly. This is Chinese.
It's like, it was easier learning to code than doing this.
Okay, so how do you get rid of an nth root?
No
You
idea.
put it to the exponent?
1 over n.
Yeah.
You raise everything to the 1 over n.
Wait, everything or just
So-
everything on top?
Everything. Because that radical's around the whole thing.
Oh my god.
Okay? Now, because the radical is around the whole thing, and I have multiplying on the top, one thing on the bottom, every one of those exponents is going to be over an n.
So that's 3 extra steps.
Okay? So, this piece right here is the same thing as x to the 3 over n, y to the 5 over n,
Wait,
all over z to the m over n.
so
Y'all good with that?
now I'm confused.
Yeah.
One
The-
over.
Oh, okay, so when it has a square root to a variable, it's gonna be the variable, or the exponents over the variable of the square root. I know it said that in
So
variable.
no matter
I want you to break
what,
down.
you have to put everything over the
Because I'm
thing.
taking the nth root of all of that stuff, which is the same thing as
To get
each
rid
piece
of
of that
the-
stuff to the 1 over n. But there's already an exponent there, so that exponent is gonna be multiplied by the 1 over n, which gives me
That's weird.
3 over n, 5 over n, and m over n,
This is why I don't go to TED Talks.
okay? Are you following this?
Yeah, we got rid of the
The
N
tops.
of usually.
The tops are added,
Added.
with these
Yes.
exponents coming to the front.
Yes.
Hang with me here. The bottom is subtracted with
Oh,
the
that.
exponent coming to the front. Okay?
I feel like I
No
knew
clue
this
what that
ago.
was, but
to get
yeah.
the final answer.
I'm writing the answer.
3.
Log base b, well, 3 over n.
Yeah.
Yeah.
3 over n. Log base b of
X
x
plus
plus
5n log v
5 over n log base b of
y minus mn
m over n
whatever
Of
log,
A.
log base b z.
To the Z.
And that's the answer.
Hold up.
Okay, that was clean.
I like that.
Very stunning.
Okay?
Does it get uglier than that?
Let's not find out.
Sure.
Yeah, you just put face in front of it. Somebody else said it.
Santiago, how you doing? Are you? Best you go. You doing okay?
Oh, I see it now.
Luke? Leilani, you weren't here yesterday either. How you doing?
Oh, hey, you need to make the joke. Are you making fun of me?
No.
Never.
Now I'm
Never.
insecure.
I'm
Even more than I was yesterday. I cried in the dentist office when they left.
Bummer. We'll just strap you in a chair. All good. Okay,
I'll cry again.
here's where we are.
I'm forced to.
What you saw me do was take a single log statement, right?
Yes.
Look what I started with. I started with a single log statement. We went from A to F. I took a single log statement and expanded it to making it look ugly. This next problem you're gonna do by yourself. You're going to take a multi-log statement and write it as a single log.
I can do that.
Okay, remember, if you're writing something as a single log, that means you only write the word log once. That's hence the word single. You understand single, right, Tyler? All right.
Because you're white.
Okay, I
That
got it.
was very uncalled for.
Okay,
But
write
yes,
that.
I do.
Tyler
I do know.
wasn't always single. Remember that?
Okay, give it a shot. I want y'all to write that as a single log statement.
No one we were funny. I'm done.
I don't see anything written down.
Mr. McCrory. I can't even show you that because I dyslexia the N and wrote the N's or an N, so I'm dumb.
You got it. You're closer than you might think.
It's not even fully. I mean,
Okay, you misspelled that.
I know I did. I wrote I'm dumb. I spelled dumb wrong. Log base root 3 up to back
Huh?
can we go back to the other side?
Shut up.
Okay, you're missing something.
Tyler,
You're missing something.
stop, please.
Did you figure it out? That's right. Where's your answer?
Shows that's right.
Yes, it is.
No, I'm scared.
I feel like I'm missing something because I don't know what to do with that.
Well, you're supposed to be writing both. That's the answer.
Okay, it is.
Did you say I'm supposed to be writing the log
I
A?
have no idea what it is.
It's okay.
Wait, am I close?
You're so close, you're right.
I'm right?
Yes.
And I wasn't even
Okay.
here yesterday.
The two people that weren't here yesterday got it right.
No.
They're not the only ones.
Must be pretty
What you got?
close.
No, I'm not
That's
finished.
what you got
I
so
don't know,
far.
I put
I don't
log
know.
base 3, and then x plus x
I mean,
plus
what you written down so far is correct. Okay,
Keep the parentheses. Don't change them.
Y'all did better than second and fourth period. Great job. Okay, the positive ones go on top. The negative one goes on bottom. So a single log statement. Okay, fine. Log base 3. This thing and this thing go on top. So x plus 2 and x. There they are.
Well, I know that, but why would they
And
be
we're done.
like that? That looks
So I just
stupid.
I got it right.
I hate
I
Okay.
don't know who I
Okay.
distribute it or can you distribute it.
So you wrote x squared plus 2x? I mean, that's technically right. Yeah. Good job. Okay, try this next one.
Goodness gracious.
I don't remember it.
I know, I'm trying to remember it.
I don't. I can't recall.
I will remember it for you.
Okay.
For what?
Okay, try that one.
Wait a minute, what did we, what is the, I just need to know one thing.
We were trying to write that last problem.
Is that right?
Yes, it is.
Yeah,
It's right.
What?
play on player.
I think I
Check.
got it right.
Oh,
Yep, that makes more sense.
Wait, can I turn off my stuff? I'm doing it.
Where's 210?
Was it in?
Almost.
Yes, amigos.
Okay. Yeah, most of you had it already. Log base A. That 2 comes over here. The 3 comes over here. They're exponents. M squared over n cubed. Okay.
was it the crown? No. Dolphin? No.
Great job, guys.
Bowling?
Hold on.
Bowling?
Hey, Tyler, you have trouble?
No.
You remember it now?
Yeah.
Mr. McCrory.
I love how you completely forgot I wasn't here yesterday.